Assalamualaikum warahmatullahi wabarakatuh. My name is Surya Rifqi Fadhilah and I'm from Group 7 Class 2 CC8. In this video, me and my friends Muhammad Yafie, Gustaff, and Kennan Fattahilah Herdyhanto will presenting our ISAS assignment, and our ISAS title is Implementation of Graham Scan Algorithm. In this presentation, we have three contents. The first one is definition of convex hull. It will be presented by myself, and the next one is the Graham scan algorithm. It will be presented by my friend Muhammad Yafie Gustaff, and the last one is the program implementation of the algorithm. It will be presented by my friend Kennan Fattahilah. Definition of convex hull. Convex hull is a classic problem in computational geometry. The problem is simply described in a two-dimensional space as a seeker of subset of the set of points in the field, so that if the dots are made of polygon, it will form a convex polygon. And we can say the polygon is convex if it's depicted a line linking between points. Then there is no line that cut out the outline that is the outer boundary of the polygon. So convex hull is a geometric object or something called polygon that encloses all of the sets of points. As you can see in the image, the vertices of the polygon maximize the area while it's minimizing the circumference. And where the convex hull being used? So one of the example of application in convex hull is collision avoidance. If the convex hull of a car avoids collision with obstacles, then so the car's convex hull. Since the computation of path that avoid collision is much easier in convex car, then it is often used to plan paths.
Hello, my name is Muhammad Yafie Gustaff, and I want to explain about Graham scan algorithm and how it works. First is Graham scan algorithm. Graham scan algorithm is an efficient algorithm for finding the convex hull of finite set of points in the plane with time complexity O n log n. The algorithm finds all vertices of the convex hull order along its boundary. It uses a stack to detect and remove concavities in the boundary effects. It is named after Ronald Graham, who published the original algorithm in 1972. In Jarvis algorithm, for convex hull, worst case time complexity of Jarvis algorithm is O n log 2. But using Graham scan algorithm, we can find the convex hull in on O n log n time. So how does it work? First is we search for the lowest coordinate of y point, which is here, and then we link it on another point like this: 1, 2, 3, 4, 5, 6, and 7. So we'll, and after that we'll link it clockwise, and after that we move here. In here, as you can see, there's P, C, and N. P means previous, and C means current, and N means next. So in here you can see PCN. In this point, it's a left turn, which is clockwise, so we can accept the point C. And next we go to here PCN. In this we can see is a right turn, so it's not a clockwise, so we can reject the C point. And after that we start again from here. BCN is a left turn, so we can accept the C point, and same as this point and this point too is a left turn, so we can accept both of this point. So next here PCN is also a left turn, we can accept it, but we search the farthest point, so we move to here. PCN is farther than this, but it's not a left turn, so we reject the C. So we back from here again. SPCN is the farthest line outlines, and is also a left turn, so we can accept the C, and there's a convex hull.
Assalamualaikum warahmatullahi wabarakatuh. My name is Kennan Fattahilah. In this section, I want to demonstrate our application about implementation of Graham scan algorithm to find a convex hull. First, I want to run our program. Okay, the first scene we saw in the screen are just random points with the starting or pivot with indicated with green color. The algorithm itself need a few steps to find and create a convex hull. The first step is find the most bottom point and make it as a starting point, right? Like on our screen, and then it will sort all the others point that has a counterclockwise orientation from the pivot, and then like the I'm sorry. Okay, and now our points have a sorted order with index 1, 2, 3 until 15, and then the algorithm will scan which point is the right hole. After that, we finally can create and show the convex hole to the screen. It is basically just a polygon that enclose all the inner points. Okay, now our program is also can handle random, generate random and automatically find the convex hole. I want to demonstrate on the screen. It will generate random points and then automatically find the right convex hole. Okay, now I want to go to the code and explain the important thing about the algorithm or the implementation itself in our program. There is some wrapper here like a renderer and anything else, but I want to focus about the algorithm itself. First, we create an object, Graham scan object, and then after we instantiate the object, the constructor will call a refresh point function. It will generate random points and then find the starting point, and after that we sort the points with or based on the orientation from the starting point, and then we first push the starting point and index 1 element on index 1 into the stack, but in this case I'm using an array or a vector in C++, and then finally we scan which point is a correct point for the whole. After the iteration is finished, we finally can print the result into the screen. Thank you.